All right, guys. So today we talked about stem and leaf plots. So a stem and a leaf plot is a graphical display where the data is organized by place value. So a stem and leaf plot is a different type of statistical display, and it's broken up by place value. So the last digit is the leaf. So our leaves over here are our smallest place values, and then everything else is the stem. So if we're looking at a stem and leaf plot, this stem and leaf plot represents the math test scores. And we're looking at a 5 in the tens place and a 0 in the ones place. Okay, so when we put those two numbers together, that's a 50. So let's look at the next one. We have a 5 in the tens place and an 8 in the ones place. So this number here represents 58. Okay, all right, let's look at the next row. We've got an 8 in the tens place and we have a 6 in the ones place. When we put those two together, that gives us 86. So that's how you read a stem and leaf plot. It's broken up into place values. And the reason that people make a stem and leaf plot is so they don't have to write as many numbers. So instead of writing a 50, a 58, we just know that there's a 5 here and a 0 in the ones place. So that's 50. Next one is 58, 64, 68. Okay. All right. So what we're going to focus on today is actually making them. So how to create. The first thing we're going to do is we're going to arrange our data in ascending order. So that means ascending from least to greatest, okay? We're going to determine the place value of the smallest digit. So in this example, the smallest place value was the ones place. So all of those are your leaves. Then anything else, anything bigger than your smallest place value is going to be your stem. You're going to put the stems on the left and you're going to put the leaves on the right. You're going to create a key, okay, that appropriately tells people what the place value is. Then you're going to create a title so people can see the attributes of your data. Okay, so let's take a look. Here's our data set. It says Mr. Spatola recorded the data set in his 6th grade PE class based on how many push-ups that each student could do in a minute. Okay, so he was like, everybody's got 60 seconds, and then he recorded how many each person could do. What we're going to do is we're going to put it in a stem and leaf plot. Now, when I'm working with stem and leaf plots, I'm going to arrange my data in ascending order, but I'm going to do it vertically so that I can easily see the place value, okay? So ascending means least to greatest, so we're going to start with the least, and I see Chelsea had the least here, so I'm going to put a 7. Then Bella had a 9, so I've got a 9, okay? Then it looks like we have a 12. Amanda got a 12. Okay, we have a Michael with 14. Okay. Then we have Maria. She had 19. Oh, sorry. We had Sarah with 18 and then Maria with 19. Okay. Notice how I'm putting the ones place here, the tens place here. That's going to really help us out here in a minute. So as you order for a stem and leaf plot, make it vertical so that we can look at those place values really easy. All right, so we were at 19. So next, it doesn't look like we have any 20s, okay? But we have a 31 for Brandon. We have a 32 for Jeff, a 33 for Ryan, a 37 for John, 38 for Jessica, okay? Then we're going to move into our 40s. We have a 42 for Kelsey. We have a 44 for Josh. We have a 47 for Sean. And then we're going to move into our 50s. We have a 50 for Katie and a 56 for Chris. And that looks like everybody. Okay. The way that we can, if you have it on your paper, you can mark it off. Also, we can count our numbers and make sure it matches how many are in our data set. Okay. And so we've ordered our data from least to greatest, and we've done that vertically so that we can look at our place values. And I see that the smallest place value that we have is our ones place, okay? Our smallest place value is this column, is our ones place. So all of those numbers are going to be our leaves, okay? Now, everything else is going to be our stem. Now, what would go here, since we don't have anything in the tens place, we know that this is a 0 and this is a 0, okay? So 0 is going to be our first stem, okay? Then we have a 1. 1 is going to be our stem. We've got some 3s, we've got some 4s, we've got some 5s. So the way that you're going to make a stem is you're not going to skip numbers. The lowest stem we have is a 0, the highest stem we have is a 5. Okay, so on my stem and leaf plot, I'm going to come straight over here and I'm going to start with 0 and then I'm going to count it down. I've got 1, 2, 3, 4, and 5. Okay, so from 0 to 5, those are my stems. Now we're going to put the leaves where they go. Okay, 2 numbers have a 0 as their stem, and that is 7 and 9. Now notice I separate mine with a comma so that's easy to see. You guys do the same thing. Okay, so 0, 7 means 7, 0, 9 means 9. Now for our stem, for our 1, we have a 2 for 12, a 4 for 14, an 8, and a 9. So we have 12, 14, 18, and 19, separated by commas again. Okay, now we don't have a single stem for 2, okay, but we have to leave it there because it represents a part of our data. So I'm going to leave 2 blank because I don't have any leaves that go with it. Now if I look at my 3s, I have 31, 2, 3, and 7, and 38. Okay, so my leaves are going to be 1, 2, 3, 7, and 8 to represent 31, 32, 33, 37, and 38. Okay. Now we're looking for our 4. We have a 2, a 4, and a 7 to represent 42, 44, and 47. Okay. Last but not least, we have our 50s. So I have a 0 and a 6, and that represents 50 and 6. Okay. Now we need a key and a title. Title for this one is 6th grade student push-ups because that's the data that we collected. This is how many students could do push-ups in 60 seconds, sorry. And all the key is like when you look at a map and it tells you what each little symbol means. So our key, all it has to say, I just take, it's like a little screenshot of the beginning here. So I have a 0 and a line and a 7. So I draw that and I just tell people that that equals 7. Okay, so that they know that this is not a decimal, that this is just the ones place, it means 7. Okay, now you'll notice this one down here looks a little bit different. This is called a double stem and leaf plot. And the reason that we make a double stem and leaf plot is so we can compare 2 pieces or 2 different groupings within the same set of data. Okay, so we're going to take a look at this one and we're going to compare the push-ups of boys to girls. Okay, so I'm going to put my boys over here on the left and I'm going to put my girls over here on the right. Okay, now we're using the exact same set of data. So we're going to use the exact same set of stems. Stems go in the middle on a double stem and leaf plot. So I've got 0, 1, 2, 3, 4, and 5. Now, as we put the leaves on a double stem and leaf plot, you have to decide which side they go on. So if it was a girl that was doing those push-ups, it's going to go over here on the right. And if it was a boy that had done those push-ups, it's going to go over here on the left. Okay. So if we look at our data set, we're using the same piece of data. So it's already organized for us, which is really nice. We have a 7. A 7 was Chelsea. So it's going to come over here on the girl's side. 9 was Bella, which is also a girl. So that's why this one is over here is 2. Okay. Then our next number was a 12. And if you look, our 12 was Amanda. So that's a girl. We're going to put our 2 here. Our 14, Michael, was a boy. So the 4 is going to go on this side over here. Okay, so the 14 is on this side. Now, when you read a double stem and leaf plot, you kind of have to train your brain a little bit backwards because the leaves are the smallest place value. So this doesn't represent 41, it represents 14. Okay, you got to train your brain a little bit backwards to read these. All right, so then we're looking at our 18. 18 was Sarah, so I'm going to put my 8 here. 19 was Maria, so that's a girl as well, so I'm going to put my 9 over here. All right, now we still don't have any 2s, so it's going to be blank, but let's look at our 30s. I've got a 31 for Brandon, so it's going to go on the boys' side. I had a 32 for Jeff, so it's going to go on the boys' side. A 33 for Ryan, so it's going to go on the boys' side. A 37 for John, okay? So it's going to go on the boys' side, and a 38 for Jessica. So that's going to go over here on the girls' side. Now let's look at our 40s. 42 was for Kelsey, that's a girl. So we're going to come over here, put it on the girls' side. A 44 for Josh, that's going to go on the boys' side. A 47 for Sean, so it's going to go on the boys' side. And then let's look at our 50s. I've got a 50 for Katie, that's a girl. She's going to go on this side. And then a 56 for Chris. So that's going to go over here on the boys' side. Okay, so the reason that we make a stem and leaf plot, a double stem and leaf plot, is so that we can see our different differences within the data in a same set. Okay, so if you look at our first stem and leaf plot, if we're looking at the shape, most of our data falls towards the center, and then we have a little bit on each extreme. Okay, so but most of our data falls towards the center, and we have a little bit on each extreme. So that would mean that we have a bell or a normal distribution when we look at the whole class. Okay, now when we break it up, if we look at the boys' data, most of the data falls towards the upper extreme, and we just have a little bit towards the lower extreme, or a little tail here. If you think about our statistical display shapes, the one that says most of the data falls towards the upper extreme is skewed left. So the boys' data is skewed left. Most of the data falls towards the upper extreme. If we look at the girls' data, most of the data falls towards the lower extreme, okay, with a little tail off to the upper extreme. When most of the data falls towards the lower extreme, that's considered skewed right. So the girls' data is skewed right. So that's a comparison that we can make using our stem and leaf plot.